Hello, my name is Bill Kinney and this is video number 27 on my series in Arithmetic, Algebra, and Graphing. Video number 27, sub-series on decimals, real numbers, and percentages with an emphasis on calculator usage, part 6. In the last video we looked at a bunch of examples of fraction to decimal conversions, including these and some other ones, and also thought about them as percentages, and we saw that it seems like every time we convert a fraction to a decimal that we get some sort of repeating pattern. And let's just try one more example of that and practice using long division. Let's say we want to convert 5/21 to a decimal. Well, again, you want to do a long division if you're doing it without a calculator. You want to put the numerator inside there and the denominator outside over there. Think of 5 as 5.0 repeating. Put the decimal up here. Now sort of ignore the decimal, make sure things line up though. 21 doesn't go into 5, but it does go into 50. How many times? It goes in twice. 2 times 21 is 42. 50 minus 42 is 8. Bring down the 0 there. Let's write 80. 21 goes into 80 3 times, not quite 4 times. 3 times. 3 times 21 is 63. 80 minus 63 is 17. Bring down this 0. Hopefully you can continue doing this in your head. 21 goes into 170 how many times? Does it go in 8 times? Yes. 8 times 20 is 160. 8 times 21 is 168. It's going to go in 8 times. With a remainder of 2. Bring down this 0 here. You've got a 21 doesn't go into 20. It goes in 0 times, you might say. I'll put a 0 up there. Put a 0 down there. The remainder of 20. It does go into 200, and I could have brought down the other 0 from there right away. But I do need to make sure I put a 0 up there. How many times does 21 go into 200? It's going to go in 9 times. This is going to be a 189. Remainder of 11. We're getting close to the repeating pattern. I think we are, but just hang on here. So now we have 110 down there when I bring down the 0. 21, how many times does it go into 110? It goes in 5 times. 5 times 21 is 105. Yeah, now we're getting there. Got a remainder of 5 there, 110 minus 105. Bring down the next 0, I get a 50, which matches the initial 50 that I was thinking of up here. So from here on out, the pattern is going to repeat. I'm going to get a 2, then a 3, then an 8, 0, 9, 5 again. And that'll go on forever and ever. Check it with your calculator. 5/21 is 0.23809. 5, and that's the part that goes on forever and ever. This will happen indeed with any rational number. You will ultimately get some sort of repeating pattern. Can you go the other way? Meaning, can you start with a decimal that has a repeating pattern and figure out what fraction it is? Well, let me just do a simple example that we already know the answer to. 0.3 repeating. Is there a way on this kind of calculator, for example, to see what fraction that is if you didn't happen to know it? Turns out you can. You got to put enough 3's here. I'm not exactly sure how many 3's you have to put. I'll put a lot of them just to be safe. If I hit the math button on this calculator, which is right here, not all calculators can do this. There's a button that says math right there. Hit that, and then choose this first option that says frac. Enter that. Enter it again. It has converted it to 1/3, even though I only had finitely many 3's up there. Evidently the calculator is interpreting me as meaning infinitely many 3's when I do that, and it is converting it to 1/3. But what if you didn't have a calculator that could do that? Well, we're going to do a little algebra to figure this out. When I've done a little bit of algebra before, I've used question marks to indicate unknowns, and I could continue doing that, but I think I will go ahead and use the standard letter for unknowns, and that is the letter X. So X is a symbol that's representing 0.3 repeating. And I'm wondering what fraction is X? What rational number is it? Of course, I already know the answer is 1/3, but how could we figure that out? A little bit of algebra trickery, we might say. I'm going to multiply both sides of this equation by 10 and put the answer up here. Let's do it on the right first. What happens when I multiply this by 10? Well, when you multiply by 10 with decimals, it's very easy. You just move the decimal one place to the right. So I'm going to get 3.333333 repeating forever. What happens when I multiply x by 10, where x is an unknown rational number, an unknown fraction? Well, since you don't know x, you can't really write it down as a number, but you can write it down as a symbol. 10 times x. That dot represents multiplication. And in fact, a little hint here about algebra, when you've got a specific number times an unknown, you often don't even bother putting the dot in there, you just write it as 10x. It means 10 times x when you see that kind of thing. Well, so how is this helpful? You stare at it for a while and then you notice that, hey, if I look at the part to the right of the decimal, these things line up exactly. They're the same decimal part to the right of the decimal. That would mean if I subtracted these numbers, that those would all go away. 3.333 repeating minus 0.333 repeating. All the 3's after the decimal are going to convert to 0 when I do the subtraction. This is going to equal 3, or 3.000 repeating if you prefer. Interesting. What happens when I subtract 10x minus x? I'll explain why I'm doing that in a second. Can you do that kind of thing? Yes, you can. Now, if you think of x as being an object like apples, this is sort of saying, what if I had 10 apples and I subtract 1 apple? Well, of course, you'd have 9 apples. So is the answer truly 9x? Is 10x minus x 9x? It is. Could you think of it algebraically? Yes, you can. You can use the distributive property to factor out the x. What was the distributive property? The distributive property said that, for example, 2 times 3 plus 4, is 2 times 3 plus 2 times 4. Or for that matter, 2 times 5 minus 3 is 2 times 5 minus 2 times 3. The x is playing the role of the 2 here. Focus on this one. I could put the 2 on the other side here. I could have 5 minus 3 and then times 2 over here if I wanted to. The x is kind of acting like the 2. You can take the x here and you could distribute it as 10 times x minus 1 times x. Well, that's the same as this. When you just see an x there, that's the same as 1 times x. It is true that 10x minus x is 9x. How is this helpful? Well, going back to the original thing here, 10x equals this, x equals this. Here I found that 3.3 repeating minus 0.3 repeating is exactly 3. Because 10x equals that, and x equals that, that means 9x has to equal 3. I'm subtracting, in essence, one equation from the other. I'm taking the top equation here and subtracting the bottom one. If 10x equals that and x equals that, then 10x minus x should equal this minus this. 9x should equal 3. If I divide both sides by 9, so that the 9's divide out over there, that means x equals 3/9, which is the same as 1/3. So there's an algebraic way to see that that repeating decimal is 1/3. We'll do a harder example in the next video.